In this video, we're going to get some more practice factoring trinomials with a leading coefficient of 1 without having a lot of steps or things that we're walking through in terms of processes, just kind of talking through it. Okay, so in this first example, t squared plus 29t plus 100. Okay, so in this case, let me write what I already know. I'm trying to factor this into the product of two binomials. Okay, and I know that t times t is t squared, right? And I know that I've got two numbers that have to multiply to give 100. And they have to add to give 29. So to have two numbers that multiply to give you positive 100, they either both have to be positive or they both have to be negative. If they were both negative, then the sum of them would also be negative, and the sum that we need them to have is positive 29. So I'm going with the fact that we're going to have a positive number in both cases, all right? And that's actually a pretty good bet. When you have a trinomial and all the signs are positive, then everything in your factoring will be positive too. Okay, so now we're looking for, you can write out the factor pairs if you wish. That little treasure map might be useful to you. So we're looking for two numbers that multiply to give us 100 and add to give us 29. Okay, and so you can go through them like 1 times 100, 2 times 50, 3 doesn't go in there, 4 times 25. Ooh, 4 times 25. Would that work? 4 and 25 is 29. So if 4 and 25 are the factoring numbers, then we would have t plus 4 and t plus 25 as our factors. Okay, now does that work? Let's check it. Okay, so t plus 4 times t plus 25. If we FOIL it, t times t is t squared. T times 25 is plus 25t. And 4 times t is plus 4t. And 4 times 25 is 100. Okay, so we have t squared. 25t and 4t is 29t. Plus 100. Okay, very good. It checks out. Okay, now in this next example, we have x squared minus 9x minus 4. Okay, so I know, since we have a minus 4 as our constant term, that because it's negative, one of the terms has to be positive and one has to be negative. Okay, so we have x times x is x squared. One of these is going to be positive and one of those numbers is going to be negative. Okay, so I'm looking for factors of negative 4 that add to negative 9. Okay, we'll do our little treasure map here. So we want them to multiply to give negative 4 and add to give negative 9. So we could have 1 and negative 4. That would give us negative 3. We could have negative 1 and positive 4. That would give us positive 3. We could have negative 2 and positive 2. That would give us 0. So there aren't any other factors of 4, right? We're dealing with 1 times 4 or 2 times 2 with the appropriate signs there. None of those combinations are ever going to get us to negative 9. Okay, so what do we say about this? This trinomial is what we call prime. Means it's not factorable. Okay, we can't split it into the product of two binomials. So, which is fine. Not every trinomial is going to factor. So that's one thing that you need to learn around all of this too. This works for some special cases. So it's important to remember one of the reasons that we're doing all this factoring is that it can be very useful to have things in a product versus a sum. When you go to solve an equation, for instance, as we'll learn later on algebraically, and so sometimes if you can't get it into a product, it doesn't mean that this equation, if we set it equal to something, isn't going to have a solution. It just may mean that we can't use this method to find it, which is okay. All right, so now let's look at this one down here, y squared minus y plus 25. Okay, so in this case, we're going to have y times y, which is y squared, right? And the product that we're looking for is 25, positive 25. So that means they either both have to be positive or they both have to be negative. But the sum is negative. So that means that both of the numbers we're looking for are negative. Our little treasure map, we're looking for two numbers that multiply to give us 25 and add to negative 10. Negative 1 and negative 25 is negative 26. Negative 5 and negative 5, that would work, wouldn't it? Negative 5 times negative 5 is positive 25, but negative 5 minus 5 is negative 10. Okay, so our factors would be y minus 5 and y minus 5. Checking this, in the FOILing process, y times y is y squared. And then in the middle term, we're going to have y times negative 5, which is minus 5y, twice, right? Minus 5y minus 5y. Negative 5 times negative 5 is 25. Okay, so we have y squared minus 10y plus 25. Yes, it works. Okay. Also, just FYI, when you factor and you get the same binomial squared, you can write it that way. You can say y minus 5 quantity squared. That's totally okay too. Okay, so moving on to this last example, z squared plus 11z minus 80. Okay, so our variable is z. Z times z is z squared. And what are our signs on this? So we're looking for two numbers that give us negative 80, right? So one of them has to be positive and one of them has to be negative, right? And they have to sum to 11. Okay, so no combination of 1 and 80, whether positive or negative, is going to get to 11, right? What else is possible? 2 times 40, that won't do it either. 4 times 20, no, that's not it. 5 times 16, right? If we had a 16 and we subtracted 5, would that give us 11? Yes, it would. Okay, so I'm going to have z plus 16 and z minus 5 as factors. So checking this with z plus 16 times z minus 5, do we get our original expression? So z times z is z squared. In the middle, so our first is z times z squared. Our outer will be minus 5z, and our inner will be plus 16z. And our last will be minus 16 times negative 5, which is minus 80. Okay, so z squared, negative 5 plus 16 is positive 11z minus 80. That is indeed what we started with. Okay, I know that algebraically speaking, some of this can feel just a little bit like, well, why are we doing this? And factoring is one of those skills that you just need to do more interesting things later in the algebraic process. So get some practice with it and get really good at it because you're going to need it.